Well, let's talk about wind a little bit. I think we have a slide showing the pattern of wind. Can we see that slide? All right, so wind speeds at 100 meters altitude.
Yeah, that's 100 meters above the ground level.
And which is the highest winds, the blues or the reds?
Well, the reds are the highest winds here. And what this indicates, in North America, the fastest winds are in the Great Plains and offshore, the East Coast and the West Coast.
Because there's no mountains obstructing them?
Yeah, when you have friction such as buildings or mountains, but even over mountains, the wind tends to converge and you can get fast winds at the top of the mountains, but generally you get a lot of roughness, so that slows down the winds. But this slide is interesting because it shows that there's enough wind to power the world around 7 times over for all purposes with wind. But you really want to combine wind and solar together because the power demand is really what you need to match. And the sun doesn't always shine, the wind doesn't always blow, but wind and solar are very complementary in nature, such that when the wind is not blowing during the day, the sun is usually shining and vice versa. So if you combine wind and solar in optimal proportions and you use something else like hydroelectric to fill in the gaps, you can actually match the power demand extremely well. And so this quells one of the biggest issues with renewable energy, is that it's what's called intermittent. And the grid operators always worry, well, you won't have enough wind on a certain day, you won't have enough solar, so therefore the grid might not be reliable, you might have blackouts. But in fact, it's been shown in several studies now that this isn't the case if you optimize the grid properly.
Now, I think we have a slide that shows both wind and also water and wind, how wind creates waves that we can get electricity from. Maybe we can take a look at that slide.
Yeah.
Okay, so I can see the windmills on the left. Now, what are those objects on the right? How did they generate electricity?
Well, on the right, those are wave devices, and they take advantage of the up and down motion of the waves to generate electricity. And there's a cable that goes from each device underwater to the shore that sends the electricity to the shore. And so wave power, well, you need wind to drive waves, but the waves are actually more steady than the wind, or the wind might be more intermittent. The waves are kind of more steady.
Well, we have tides all the time anyway, whether there are winds or not.
Yeah, well, you also have tides too, which are a little bit different than the waves we're talking about. So there's another device that you can actually take advantage of the motion of the tides to get energy as well. But the wave power is driven primarily by the winds. And I think there's another slide here that shows that by combining wind and wave power, you can actually provide either smoother output.
Right, so there it is. So yeah. At times when one source isn't generating anything, the other one might be, and vice versa.
Right. If you combine wind power plus wave power, even at the same location, you can get a smoother overall profile of the output, which makes it a little bit easier to match the power demand on the grid.
Now, are these technologies really ready for prime time, really ready to scale up to replace fossil fuels, or do we still need a few more scientific breakthroughs?
Well, wind and solar, we don't need scientific breakthroughs. I mean, last year, in fact, 50% of all the new electric power in the United States was wind plus solar. And in Europe, it was over 60%. So these are ready for prime time. However, we need to go to 99% each year, or even 100% wind and solar if we want to convert everything to clean electricity. Because if we have half of all new power being coal or gas each year, which is what we currently have, then that means these plants are going to be there for 30 years or so, and we're not going to solve the climate and pollution problems that we need to.
Now, can we use the existing infrastructure with these new power sources? So in other words, instead of a coal-fired plant, you have a solar plant, but it's still using the same wires to deliver the electricity to somebody's house.
Yeah, so probably the biggest barrier is transmission. We can use substantially the current transmission system if we put in lots of wind and solar, but we will need the wind often is in places that's far away, like in the Great Plains, but it could be close, like offshore, especially the East Coast, which is the biggest untapped resource of wind in the world, basically, which is not far from load centers. And solar is usually in desert regions or in southern latitudes, and you might need to increase some of the local transmission. There are transmission lines already crisscrossing the US, for example, that can be utilized, and you might just have to increase the size of the lines rather than create new pathways for the most part.
Is it possible for individual residences or buildings to generate all of their own electricity through wind and solar without having to be connected to a grid at all?
Yeah, so this is the idea of distributed energy, that you have solar panels on everybody's roof. In some places where you have good backyard wind, you can have your own small turbines. And so this is an idea where you can be disconnected from the grid and generate your own electricity. But there is some advantage to being connected to the grid, because if you're not connected to the grid, then you do definitely have to have some kind of storage, either batteries or some other type of storage, so that when the wind's not blowing, the sun's not shining, and you want to use electricity, then it's available, which you can do. But the cost of batteries right now is higher than your typical grid storage.
What are the main obstacles to implementing clean energy more rapidly?
Well, we think on a global scale and even on a countrywide scale, there's no technical or economic barrier to converting 100% to renewable clean energy for all purposes, not only in electricity, transportation, but also heating and cooling and industrial processes. The biggest barrier is barriers are social and political. It's very difficult to convince people to make changes and policymakers to make changes. There are many vested interests, so they're going to fight, because a lot of companies in the fossil fuel industries in particular, and in the vehicle industries where they produce combustion vehicles, they have a lot of vested interests, and they're going to fight because they make money on the current system. And so this is the biggest barrier to conversion. It's not a technical or economic limitation to the conversion. As we've seen, states that have a lot of wind, their price of electricity goes up less than states that don't have so much wind.
Well, if we have free enterprise and renewable energy can compete successfully economically with fossil fuels, wouldn't they just naturally take over?
It will take over, but it'll take, if we just let the current system, which has certain policies in place that tend to favor fossil fuels through subsidies in particular, even though wind and solar do get subsidies, the total integrated subsidies of fossil fuels plus the current subsidies is much greater than those from the wind and solar. And so there's no incentive for natural gas, for example, to go out of business. So they're going to keep running. As I said, we need to go to 100% each year new energy. And right now we're at 50% in the US, but if you go outside the US or outside of Europe, you still have a lot of fossil fuels being developed every year. And to get to 100%, you really need aggressive policies put in place. You have to get rid of the subsidies, all the subsidies to the fossil fuels, try to put in policies, either renewable portfolio standards, but there are just literally dozens of possible policies to try to promote wind, solar, some geothermal, some tidal wave, and a little bit of hydroelectricity. But hydroelectric, we're not going to increase very much, if at all. It's just really utilizing better the existing hydroelectricity.
Well, aren't there some government incentives now for using renewable energy? So if you put on solar panels on your house, you get all kinds of tax breaks?
Oh, there are. So there are subsidies right now to solar and wind, but at the same time, there are subsidies to the fossil fuel industry. Just to give an example, it was around 2000, these are maybe a little older numbers, but 2003 to 2008, the fossil fuel industry in the US received about $70 or $75 billion in subsidies, whereas wind plus solar received about $5 billion. So there are subsidies to wind and solar, but there are also subsidies to these fossil fuels through tax breaks, through direct payments, and through health costs, even like the black lung program that coal gets. They've been paying out billions of dollars since the early 1970s.
Is it possible that the big fossil fuel companies would become leaders in moving over into renewable fuels? So instead of thinking of themselves as oil companies, if they thought of themselves as energy companies trying to sell energy however it's manufactured?